This is Capstone Design Team 3. Our project is Turbine Engine Performance. Our team is comprised of Bobby Beggs, Allison Dorn, Mitch Fitzpatrick, Joshua Gobrogge, Brendan Klynstra, and Ben Wiegand. Our primary advisor is Dr. Johnson. Our customer is the Air Force Research Laboratory, and our customer contact is Dr. Tajiri.
To begin, a problem that turbine engines have in our customer's application is windmilling. Windmilling is engine rotation without lubrication during passive flight. Team 3 must prohibit windmilling to ensure the engine is undamaged when enabled. While solving the problem of windmilling, the engine will gain the capability of thrust vectoring. This gain will decrease the cross-sectional area of the vehicle the engine is attached to and increase the vehicle's maneuverability.
The main objectives for this project are to prevent engine windmilling during passive flight at Mach 0.8 and to add 10 degrees or more of thrust vectoring capability. The addition of an anti-windmilling device increases engine reliability by reducing wear and possible failure while the vehicle is being towed. Thrust vectoring adds maneuvering capabilities not possible with traditional control surfaces, such as flaps and rudders. The video shown is one such example of a maneuver only possible with thrust vectoring.
Our solution consists of a circular to rectangular nozzle, a collar to direct the thrust, a vacuum pump to actuate thrust vectoring, a motor to turn the nozzle, and a plug to prevent windmilling. Computational fluid dynamic models show our solution is capable of 25 degrees of thrust vectoring while in flight. Tests in the anti-windmilling test rig showed that the turbine was not able to windmill at 0.8 Mach.
Our next step would be to manufacture a physical prototype to validate our design. The thrust vectoring system would be tested and validated using a FLIR thermal imaging camera to document the thrust vectoring angles achieved, and the anti-windmilling system would be tested using the anti-windmilling test rig design provided by the Air Force. We would like to acknowledge these individuals for their help and support of our team.